Hey everybody, welcome back to the rest of Chapter 8 or Unit 8. Now I'm changing the titles a little bit for us, but today we're going to learn how to find what's called the greatest common factor of a polynomial. Now you've learned greatest common factor before. Greatest common factor is the largest number that goes into a set of integers listed. Okay, so you can see we are talking still in the same eligible content of the keystones. And so now this is not like the technical definition, but if somebody's like, what is the greatest common factor? The greatest common factor is the biggest or the greatest thing or term that goes into each term. So for example, let's say we have a binomial 2x minus 8. Well, what goes into 2x that also goes into 8? What are factors of 2x and 8? Well, the biggest thing or the largest would be a 2. So you divide each of these items by 2, you put the 2 out front, and you're left with x minus 4. Now, it will become more difficult, as we move along. I have a cold, I'm sorry. Let's say we have this binomial instead. What's the biggest integer or thing, that a factor of 12 and 32? Well, 4 is the largest integer that goes into 12 and 32. Now, we have x squared and x. So how many x's go into each of those? Just a single x. And then if we have y squared and y3, the largest one that goes into both would be y2. Like, you don't want to say y3 because y3 doesn't go into y2. When you factor those out, when you divide each of those by 4, you end up, like if you divide this one by 4, that's where this 3 comes from. If you take away an x, that's where this single x is left. And then if you take out a y squared, that's why there's no y squared left in this term. Divide this one by 4, you get an 8. Take out an x is gone. Take out a y or y squared, and look, you're still left with a y left. All right, before we get moving on, I think it's important that we review how to distribute. So I'm going to go ahead and get rid of all these crazy arrows, and then we'll talk about distributing. So essentially, when we factor out a GCF, we're like undoing distributing. So if we were to distribute here and here, we would get 3a times a plus a times 7, which would end up giving us 3a squared plus 7a. So we're going to undo that process today. Review again, if we were to distribute here, here, and here, we would get negative 2m times m squared. We would get negative 2m times 6m, negative 2m times negative 1, and our final answer would be negative 2m3 minus 12m2 plus 2m. So this is all review from things we have done. And then if we were to distribute here, we would get 5xy times x minus 5xy times negative 2y. Excuse me, I didn't mean this extra negative sign there. That's my fault. I apologize. Which would end up giving us 5x2y minus 10yxy2. So all of that you were already quizzed on and already have a background knowledge of how to distribute in. So today I'm going to teach you how to take a factor out. So instead of multiplying, we're actually dividing out the GCF. I apologize. So let's talk. A polynomial, by the way, that cannot be factored is called prime. So if the only thing that you can factor out, the only factor of that is a 1, we would call it prime. Now, what is the integer 14 in factored form? So this word factored form, that's what I'm trying to get you into. It's like taking two factors and multiplying. For example, 7 and 2, or maybe 1 and 14, or maybe 2 and 7, or 14 and 1. That would be the integer 14 in factored form. Now the integer 19 in factored form would just be 19 and 1. And because this is the only one that exists, or 1 and 19, that would be called prime, because 1 and itself are the only factors of it. And so that's a review of the word prime. Now, there are going to be several ways to talk about this factored form, but today we're just talking about this main concept today. Again, we're not ready to go any further. We're just going to talk about how to split it with a GCF, a greatest common factor. As we progress through the rest of this will be step 1 of everything. So we're just going to start with step 1 when it comes to getting a polynomial into factored form. So these examples, we need to write it in factored form, by finding the greatest common factor, and we can definitely check by redistributing if we so choose to. Now, I will highly encourage you to pause the video as I go and see if you can figure out the GCF before we move. So, what goes in? What are factors of 5x and what are factors of 30y? Like, what goes in? What divides evenly into 5 and 30? Well, I know that both of them can be divided by 5. Do they both have an x? No, they do not. So we are not going to factor out an x. Do they both have a y? No. Then what we say is the GCF is just 5. When we write it in factored form, we put the GCF in front, like we would be distributing it in, and we divide. This turns into a 1x, and this turns into 6y. There was an adding sign there. In order to check it, we would distribute the 5 in, just like we have been in the past, and sure enough, we would get the original binomial. I'm going to make my way through the odds. I'm going to check how long that takes me and come back and do the evens if I'm under 20 minutes. Okay, number 3. Can you think, what is the largest integer that goes into 6 and 27? Does 6 go into 6 and 27? No, it only goes into 6. Let's go lower. How about 3? Does 3 go into 6 and 27? Yes. Now you might say, hey, Miss Linda, why didn't you check 5? Because I already knew 5 is not a factor of 6. Okay, so I just thought of my factors of 6. Those are my factors of 6. I thought of the factors are the smallest one, and I found the greatest in that list that worked. Now, can I take an A out of both of these? No, because they don't both have an A. So my GCF is simply a 3. If I divide everything by a 3, this becomes 2a squared. If I divide this by a 3, I get 9. If I want to check it, I would do 3 times 2a squared, and then 3 times positive 9. And sure enough, I would get 6a squared, and I would get 27, which is the original. So there it is in factored form. Factored form means you write the factors beside each other. So one factor is 3, and the other factor is 2a plus 9, 2a squared. All right, we're going to get more difficult in number 5. Can you think of, well, which one of these numbers is smaller? 3, right? What are the factors of 3? Well, just 3 and 1. Does 3 go into 21 and into 3? Yes, it does. So I'm not going to bother with 1. So I know that at least part of the GCF is a 3. Can both of these be divided by a C? This one can, this one cannot. So I cannot divide by a C. Can they both be divided by D? Yes, they can. They both have at least one D in them. So this time the GCF includes an integer, a coefficient, and a variable. So my GCF is a 3 and a D. Now watch carefully as I divide that 3 and D out. I'll switch colors. So 21 divided by 3 makes 7. And then the C carries down. These D's subtract to be 0 with an exponent, like D1 minus D1. Minus, well, 3 divided by 3 is 1. And then this is D1, take away D1, makes D 0, so that there are no D's. I guess I could write D 0, but remember, D to the 0 is just 1 anyway. So that's my final answer. Again, you could check that by taking 3D, multiplying by 7C, and taking 3D and multiplying by -1, and sure enough, you would have 21CD, take away 3D when you multiplied, and that is the same as the original. So it asks us to write in a factored form. So here's the first factor, which is a monomial. Here's the second factor as a binomial. Number 7. I'm going to look at my smallest number first. So I have 15 as my smallest integer, my smallest coefficient. Working my way down, these are my factors of 15. I'm not bothering with 30. I always just worry about my smaller one. Does 15 work? So start with 15. Does 15 go into 15? Yes, it does. Does 15 go into 30? Yes, it does. So I'm not even going to test these smaller ones. So I know at least I have a GCF of 15. Now, does each of them have an A? Well, look at that. They both have an A. I know this one has an A squared, but this one only has 1. So you just do a single one. You do the smallest. Do they each have a single B at least? Well, yes, they do. So I'm going to also say that A and B are part of my GCF. So here's the first factor, 15AB. Now let's divide it out. Let's try carefully. I'm going to get rid of all my crossing outs. Okay. 15 divided by 15 is a 1. A2 take away A1 is A1. Like you do a subtraction, right? We learned that in chapter 7. B1 take away B1 are 0, so we're not going to write them. Minus 30 divided by 15 is 2. FYI, some kids tell me that this is 15 because they subtract, but your coefficients get divided, so I put a 2 instead. A1 take away A1 makes no A's left. B1 take away B1 makes no B's left. So my final answer is, I'm going to get rid of that 1 because keystones won't have it, or that thing. If you wanted to check it, you would do 15AB times A. Remember, we would be doing our arcs. And 15AB times negative 2. So that would be 15A2B and a negative 30AB, which if that matches the original, yes it does, I know I did it right. So the question asked for factored form. My first factor is 15AB, monomial, times my second factor, A minus 2, binomial. Okay, I'm going to keep making my way through the odds. So let's find our smallest number here. I see 18. Okay, we're going to have to put our thinking caps on. What else goes into 18? I know that 9 goes into 18. I know that 6 goes into 18, 3, 2, and 1. So does 18 go into 18? Absolutely. Does 18 go into 48? Well, I'm going to take out my handy dandy and show you that it does not. I'm going to be really embarrassed if it does, but I'm pretty certain it doesn't. I always want to think it does, but it's actually 16. So just take a look how I'm dividing over here. No. See how I got a really ugly decimal? No, I wanted that to stay there because we might actually need it as we move along. So I can't pick 18 because 18 doesn't go into 48. So I'm just going to put an X through this. Does 9 go into 18? Yes, it does. Does 9 go into 48? Well, if you're not sure, just type it over here. And no, it doesn't. So I'm going to get rid of my 9. Just going to make my way down the list. Does 6 go into 18? Well, definitely. Does 6 go into 48? Well, it sure does. See how I didn't get a decimal? 6 is my answer. Now let's talk about A's. This one has A2. This one has A1. So you have to pick the smallest. So I'm just going to pick a single A to take out. Okay? Now what about B's? Well, this one has a B1 and this one has a B1. So I have to pick a B1. This one has a C2 and this one has a C3. So you pick the smallest because like whatever you take out, you can't take out more than what you have. So I'm going to pick C2 on both of these. The cat is walking on the iPad in case you hear something. All right. So we agree they all divide by 6. They all can take out a single A. They all can take out a single B. And they all can take out a C2. So in factored form, we write that there, or we write our GCF as our first factor. And now we divide. Okay? So let's go slowly. 18 divided by 6 is a 3. If you don't believe me, check it out over here. A2, take away A1, is going to make A1 at the end. B1, take away B1, is going to make B0 at the end. So I don't write it. C2, take away C2, is going to make C2 at the end. So I don't write it. Minus 48 divided by 6 is an 8. We already said that over there. A1 take away A1 is A0, so we don't write it. B1 take away B1 is B0, so we don't write it. And C3 take away C2 is C1, so that one we do need to write. Again, you could check it by distributing, but I can just tell you because I did it here, it's right. And the keystones won't have those ones on there. So it is written in factored form because we have its monomial times the binomial that would make the original if we distribute them back together. So number 11 is here not to be a jerk and not to trick you, but it is sneaky. So we need to focus on the smaller number, which is 5. So what goes into 5? Well, just 5 and 1, right? Well, does 5 go into 5? Of course it does. Does 5 go into 13? No, it doesn't. That's an automatic GCF between the two of those is 1. Now, what about X? Does X go into them? No, it doesn't go into the second, so I got to get rid of that. What about Y? Does Y go into them? No, it doesn't. When our GCF is just a single itty-bitty 1, we could write it like that if you wanted to. But this item is prime, because if you were to divide by 1, you get itself again. So when it asks you to write it in factored form, you could actually not put the 1 in front. It would be much wiser of you just to write the word prime, because the only factor that goes into both of them is 1, so it is therefore prime, so it is therefore useless for us to divide by 1. All right, let's go to 13. Smallest number, smallest coefficient is 6. What goes into 6? 3 and 2 and 1. Let's try 6. Does 6 go into 6? Yes, it does. Does 6 go into 14? No, it does not. Let's back up. Does 3 go into 6? Yes, it does. Does 3 go into 14? No, it doesn't. Let's back up. Does 2 go in? I'm on my list. I'm just working my way down this list. Does 2 go into 6? Yes, it does. Does 2 go into 14? Yes, it does. Does 2 go into 10? Yes, it does. So we found our coefficient, our integer we're taking out is a 2. Now let's check the y's. All right, so I can definitely take out a y of some fashion because they all have a y. What's the smallest amount? Y squared, right? You guys can see it right here. See how the smallest one is a y squared? So that means each and every one is going to be taking out a y squared. Boom, 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 boom. And that is because the smallest y squared I saw, or the smallest y I saw, was y squared. So my GCF is a 2 with a y squared. So when it asks you for factored form, you write your GCF, and then you divide it out. So let's see what we get, okay? Let's change my color. 6 divided by 2 is 3. Y4, take away Y2, is going to leave me with Y2. 14 divided by 2 is a positive 7. Y3, take away Y2 is Y1. And I should have made that maybe a little bigger. Negative 10 divided by 2 is negative 5 or minus 5. Y2, take away Y2 is Y0, so I don't write it. So this time in factored form, I have a monomial and a trinomial as my final answer. Let's check out number 14, or 15, excuse me. So I'm going to look for my smallest coefficient, which is 14. What goes into 14? 7, 2, and 1, right? So which one of those? Does 14 go into 14? Absolutely. Does 14 go into 28? And if you're not sure, just take your calculator and divide, which it does. And then we know it also goes into 14. So 14 is my answer. I don't even have to bother with 7, 2, and 1. Now it's time to check out the variables. Do they each have the variable g? That is incorrect because the last term, this one right here, this term does not have a variable of g. So I'm going to erase the g. G is not part of my GCF. Do they each have an h? Absolutely. Well, what's the smallest exponent on h? Is it 2, 1, or 1? Well, the smallest exponent on h is the 2, right? Or excuse, that was silly of me, is the 1. That means we have to do h1 down here. You pick the smallest exponent of the variable. So my GCF is a 14h. Put it as the first factor. Now it's time to divide it out. 14 divided by 14 is a 1. Let's see, it definitely still has the g left. h2, take away h1 is h1. Okay, 28 divided by 14 is a 2. I need to move this parenthesis. Okay, so that was that. There's still a g left. H take away an h is h0, so I don't write it. 14 divided by 14 is a 1. H1 take away h1 is h0, so I don't write it. So my factors are 14h and gh to the first plus 2g plus 1. Okay, clarification purposes for a moment. The keystones will not put the exponent 1 or the coefficient of 1 on a variable. However, this 1 needs to stay because you have to have like a placeholder for it. That's a very important one. So this time my trinomial is gh plus 2g plus 1. All right, let's do 17, and unfortunately I don't know how to count. That should say 19. Wow, okay, so I'm really glad we're doing 17 because I want you to tell me what's the smallest coefficient. I'm really hoping you don't think 5. It's not 5. The smallest coefficient is a 1. So what goes into 1? Well, just 1 and 1, right? So my GCF is a 1 right now, because 1 is the only number I can put down here that they all divide by. You might try to say 5, but 1 doesn't divide by 5. All right, let's talk about M. So 1, 1, and 1. M, M, M. Do they all have an M? Yes, they do. What's the smallest M? M to the first. So we're only going to be taking out a single M because M to the first was the smallest. Now, N, N, N. What is the smallest exponent on N? 1, 2, or 3? Well, 1, right? So we're just going to do 1, 1, and 1. Remember, with variables, you only take out the smallest exponent on variables. Now let's do some division. So in factored form, I'm going to have this. Now let's divide it out. 1 divided by 1 is just 1. I'm not going to even bother with it. So M3 take away M1 is M2. N1 take away N1 is N0. Don't write it. Minus. Well, 1 divided by 1 is 1. M2 take away M1 is M1. N2 take away N1 is N1. Plus 5 when you divide by 1. M1 take away M1 is M0. Don't write it. And N3 take away N1 is N2. All right, let's clean this up for the keystones. They won't have a coefficient of 1, and they won't have exponents of 1. So your factors are mn and m squared minus mn plus 5n squared. Last one is number 19. We're just going to pretend like there's a 1 there. I'm just going to act like I didn't even make that mistake. There we go. Please find the smallest coefficient. Doom, doom, doom. Hopefully you're saying 15. Think of factors of 15. 15, 5, and 3 are the only factors of 15. Now let's try. Does 15 go into all 3 of these numbers evenly? No. You can see over here that it doesn't go into 20 and it doesn't go into 35 evenly because we get decimals. So let's get rid of the 15 and put an X on it. How about 5? Does 5 go into all of those? Absolutely. And you can see over here, in case you're struggling, that 5 goes into each and every one of my terms. So I'm going to go ahead and say part of my GCF is a 5. Now it's time to talk about the A's. How many A's am I able to take out or make part of my GCF? A2, A1, A1. Remember, with variables, you pick the smallest exponent. Now I do see a B. B as in boy. Can I take out any B's? Well, you might say, hey, Langella, you can take a B out right there. But does that one have a B in it up here? No. So if that's the case, we are not going to be taking out any B's. So the GCF is a 5A1. Let's write the factor here, the monomial, and let's go ahead and divide it by that. So 30, I'm going to change colors. 35 divided by 5 is 7. A2 will take away A1 is A1. 20 divided by 5 is, that's a minus 4 because of the minus sign. A1 take away A1 is A0, so none. B2 has to come down. Don't forget, it's still part of it, right? You can't just like, oh, it doesn't have a B, so I get to just pretend it didn't exist. That wouldn't be very nice. 15 divided by 5 is 3. That's positive. A1 take away A1 is A0, so I don't even bother. So this time my factors are 5A. Remember, the keystones won't have the exponent of 1. Times 7A minus 4B squared plus 3. Simply because of the time, I think I've done enough that if you have any questions, you're watching this, you can either do the evens with us in class or try them. You could even check on Mathway or PhotoMath on the GCFs, and then let me know if you have any questions on those. But between all the odds that I just did and the ones you're going to do on your practice problems should be enough for you. So here's your recap. Look at your coefficients. I really want you to tell me, I want you to focus on the factors of the smallest coefficient. Check and see if there's any variables that are common. If there is a common variable, take the one with the smallest exponent and divide all of those out. I like this tiny 4 because that's like literally the most important step. All right, so today we had keywords. We had greatest common factor and we had factored form. And I'll see you later.